Alright, boys and girls, welcome back to the drive-thru for a remix 6-6 with audio this time. We've got 14 different situations we're going to look at. We're going to try for each situation to tell, is this a function or not? If it is it linear, exponential, quadratic, or none of the above? Describe the growth and create one more representation for this relationship. So, a plumber charges a base fee of $55, service call, and $35 per hour. The relationship between the price and the hours worked. Okay, so this is a function. So this is a yes. To me, this is definitely linear, but let me tell you how I know. I'm going to make a table for my other representation. So this is part D here. If we just called the plumber and they didn't come out, but we wanted to call them to come out and just say hi to us, like in a pizza situation. So they did come out, but they didn't do any work. They did 0 hours of work. It would have been $55, okay? If they came out and spent an hour, it'd be $35 per the hour plus $55 for the visit. That's $90. If it was 2, then it'd be $125, I think. If I added another 35 to that, it would be $160. So notice that we are adding 35 for each hour. So this is linear. It's increasing. And if we wanted to do one more, if we wanted to go over and above, I would say this is y is 35x or h plus 55. That's what we're doing in all these examples. Okay, so is it a function? This one is a function because it passes the vertical line test. Okay, so yes for A. B, this is definitely quadratic. Okay, the growth is it's low. It starts low. It goes high, and then it gets low again at the end. I don't know. Don't worry about part C. You could also just say that this is a quadratic growth. Create a representation. Let's just make a table. Let's go -2, -1, 0, 1, 2. Let's just track where those points are. So -2 is -1. -1 is -4, 0 is 5, 1 is 4, and 2 is, sorry, this should be a positive 1. 1. Now, I could come up with an equation with that, and I believe that equation would be, let's see, it's definitely -x squared plus 5, is that what it is? I think that's what it would be. Okay. Number 3, well, let's just come up with, a lot of these times I do step D first. So let's see, it looks like we have a -3, -2, -1, 0, 1, 2, 3. My other representation for this is going to be a table. -3 is 8, -2 is 4, -1 is 2, 0 is 1, 2 must be a half, then a fourth, then an eighth. Okay? Yes, this is a function. This is a exponential function. I can tell by the shape of the graph that it's getting smaller and smaller and smaller each time. The growth is geometric growth. And here's another, right here is my other representation of the relationship. In case you were wondering, this would be y equals b times r to the x power. So it's going to be 1 times 1/2 to the x power. Okay? Number 4, this is a function because it's written as y equals. Anything that can be written as y equals will end up producing a function. Okay? It's definitely going to be a quadratic because of this squared. The type of growth. Oh no. Oh no. Let's undo that. Undo it. Oh no. Oh no. What had happened? Oh well. Let me pause this real quick. Alright, we're back. Okay, it's definitely going to be a quadratic because of this. That's what I had said. And it's going to be positive. It's going to be quadratic growth is the type of growth. As far as another representation for the function, let's see what we get here. If you put in a 0, this would be a good thing to put in your graphing calculator. If you put in a 0, you get a negative 2 squared is 4. 4 thirds plus 4 is 5 and 1 third. Put in a 1. You get a negative 1 squared, which is 1. This is 4 and a third. Put in a 2. You get a 0. 4. Put in a 3. You get 4 and 1 third, and that's a different representation. Alright, moving on. Number 5, this is not a function because it fails the vertical line test. Okay? This would be quadratic, but it would be x equals y squared. And I'm just going to move on. The most important thing that you can learn from 5 is that it is not a function because one vertical line intersects the graph at more than one point. Okay, for number 6, yes, this is a function. Let's rewrite it. 1/3 x minus 2/3 plus 4, which is y equals 1/3 x plus 3.3 repeating. Okay, so it's linear. It is increasing because the slope is positive, and if I wanted to write another representation, I could just sketch a line whose y-intercept was a little bit above 3 and whose slope was 1/3. Okay? The speed of the car and the distance it takes to stop when traveling at that speed. Ooh, I like this. Okay, so this one went up 37.5, and then it went up 62.5, and then it went up 87.5, and then it went up, oh dear, 112.5. Okay, now let's see what this is. So now I'm going to look at the second difference to see if it's quadratic. The second difference is always 25. Okay, so this is a tough one, but now I know that this is a function because at no point did we repeat an input value, so our function is not broke. Okay, since the second difference is constant, it's definitely quadratic. You'll notice that this particular set of points just kind of looks like this. It starts over here. Okay, it's all we're doing is we're just not seeing this other half of the parabola over there. Although I'm sure if you were driving in a negative speed, it would still take you as long to stop, or similar rules would apply. Okay? And let's see, this is another representation, so I've got them all done. We're moving on. Alright, so the relationship between the number of dots and the time At 1, we have 1 dot. At 2, we have 3 dots. At 3, we have 6 dots. At 4, we have 10 dots. Is this a function? Yes, it is a function. Is it linear? Let's see. This is plus 2, plus 3, plus 4. Notice the second difference is constant. So it is a quadratic. The type of growth is quadratic. And I think I'd like to practice coming up with an equation. This must be y equals x squared. Let's see. 1 squared is 1. 2 squared is 4. 3 squared is 9. Is this x minus 1 squared plus x? I'm not sure how I would come up with this right now, and it's not asking me to do that. So instead of coming up with an equation, come on now, come on. Why don't I just make a graph out of it? And I'll come back and do another equation later in the test review. So 1 comma 1, 2 comma 3, 3 comma 6, there we go. Okay? Number 9. The rate at which caffeine is eliminated from the bloodstream is about 15% per hour. The relationship between the amount of caffeine in the bloodstream and the number of hours from the time that the adult drinks the caffeinated beverage is the okay. So, let's see. 0, we have 500. It's eliminated at 15% per hour. Let me get a calculator. Okay, so if I did 85% of 500, that would be what is left after it loses 15%. So there'd be 425 milligrams after 1 hour. Then there'd be 361.25. I'm just multiplying times 0.85 every time. And then there'd be 307.0625 after 3 hours, so I'm multiplying by 0.85. Okay? So, this is definitely exponential decay, so it is decreasing exponentially. Okay? I know that our equation would be y equals 500 times 0.85 to the t, or to the x, where t is the number of hours. Okay? Alright, number 10. Every time I go over 1, I go down a half. Over 1, 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 down a half. Okay, so this is a arithmetic. It's a sequence. It is a function because it passes the vertical line test. Let's say that f of 1 is 1. And to find any number, we take the previous number and we multiply it by a half. No, we subtract a half. Idiot. And we subtract a half. Okay? Alright, let's do d first. So this is a function because we can write it as y equals. Okay? Let's FOIL. Let's practice our foiling, and that'll be a different way to write it. 4x times x is 4x squared minus 24x plus 3x minus 18. So it's 4x squared minus 21x minus 18. Okay? This is a quadratic function. It is increasing because it's positive, and that's another representation. This is another way to write this equation. Okay? Alright, so Mary's got she wants to build a rectangular flower garden surrounded by a walkway that is 4 meters wide. Oh no. Stop it. So this is 4, 4, 4, and 4. Alright. The flower garden will be 6 meters longer than it is wide. So if we call this x, that has to be x plus 6. The relationship between the width of the garden and the perimeter of the garden. So the perimeter is going to be 2 times x, which is the width, plus 2 times x plus 6. So that's going to be 4x. So 2x plus 2x plus 12. Alright, so that is arithmetic. It is a function. It's linear growth, or arithmetic growth. And here's your representation for the perimeter. Okay? But the area of the walkway, holy cow, the area of the walkway. Well, the area of the walkway is going to be, let's see, this right here will be 4x. That right there will be 4x. That right there will be 4 times x plus 6 plus 4 plus 4. So this is 4 here. And this is 4 here. So the whole thing down here is x plus 14, because it's 4 plus 4 plus 6. I hope that makes sense. This is super tough, but hey, no problem for trying it. So the area of this thing right here that I'm shading in the black is x plus 14 times, times 4. So it's 4x. Yep. No, this would be 4x squared. No, that's 4x. Yep, so it's going to be, here we go. There's 2 of these black shaded areas. So the area of the walkway would be 4 times x plus 14 times 2, because there's 2 of those, plus 4x times 2. So that would be 8x plus, what's 8 times 14? 112 plus 8x. So it's 16x plus 112. Okay, that's D. That would be linear, and the type of growth would be increasing. Don't worry about that. I might have made a mistake there, but we're moving on because we got one more page in the video. Okay, stick with it. So this would be exponential. It would be decay, because the ratio is less than 1. And yes, it is a function. And finally, number 14. This would be a function. It would be quadratic. And another way to look at it, it's definitely quadratic growth. All right, let's just look at this. Look at it as a table. -1 gives you 1. 0 is 0. 1 is 1. 2 is 4. 3 is 9. This is definitely y equals x squared. 20 minutes is too long. Boom!